to say that if we can't, the other examples of alien intelligence is that we have for the planet or lots of critters from the cetaceans on, so to speak, and I have to believe that if we could correlate kind of the experiences of those critters, cats, dogs, cockatoos, whatever else, and the vocalizations that they have and so on, and we could, that it's talk to the animals time, so to speak. I think that feels like that's the kinds of things we've learned from ChatGPT about the structure of human language. I'm quite certain that if there's any linguistic structure for other animals, it'll be similar, because it's one of the lessons of biology is there are fewer ideas than you think. These things that we have precursors in biology long ago. We may have made innovations in language, it's kind of the key innovation of our species, but whatever is there had precursors in other organisms, and that's what, and the fact that we now have this much better way of kind of teasing out a model for language in humans means we should be able to do that elsewhere as well. Okay, David is saying, ChatGPT's developers seem committed to injecting sort of political curtailments into code because to avoid it talking about controversial topics. How's that done? It's done through this reinforcement learning stage. I think maybe there's also some actual, if it's starting to use these words, just stop it type things. I think maybe that's being done a little bit more with Bing than it is with ChatGPT at this point. I think that I have to say, the one thing that I consider so far as I know, ChatGPT is a G-rated, thing, and that's an achievement in its own right. But it doesn't. Maybe I shouldn't say that because maybe there are horrible counterexamples to that. But I think that was in terms of one of the things that happens is, well, you have a bunch of humans, and they are giving it this training, and those humans have opinions, and they will have, there'll be this kind of politics or that kind of politics, or they'll believe in this or that or the other, and they are, whether purposefully or not, they're going to impose those opinions, because there is no, the opinion is what you're doing when you tell ChatGPT that essay is good, that essay isn't good. At some level that's an opinion. Now, that opinion may or may not be colored into something that is about politics or something like that, but it's sort of inevitable that you have that. I mean, I have to say, something I've thought about a little bit in connection with general sort of AI injection into sort of the things we see in the world, like social media content and so on. I tend to think that the right way to solve this is to say, okay, let's have multiple, chatbots or whatever, and they are in effect trained with different criteria by different groups under different banners, so to speak, and you get to pick the banner of chatbot that you want to be using, and then you're happy because you're not seeing things that horrify you and so on, and you can discuss whether you want to pick the chatbot that accepts the most diverse views, or whether you want to that's sort of throws one back into kind of standard issues of political philosophy and things like this. I mean, I think the thing to realize is that there's sort of an ethics, one wants to put ethics somehow into what's going on, but when one says, let's have the AIs, do the ethics, it's like, that's hopeless. Ethics is there is no sort of mathematically definable perfect ethics. Ethics is the way humans want things to be. And then you have to choose, well, is it the average ethics? Is it the ethics which makes only 5% of the people unhappy? Is it this, that, and the other? These are old questions of political philosophy that don't really have, so far as we know, good answers. But once thrown into those questions, there's no, oh, we'll get a machine to do it and it'll be perfect. It won't happen, because these are questions that aren't solvable for a machine, because they're questions that, in a sense, come right from us. These are, the thing to realize about ChatGPT in general, ChatGPT is a mirror on us. It's taken what we wrote on the web, so to speak, in aggregate, and it's reflecting that back to us. So insofar as it does goofy things and says goofy things, that's really on us. I mean, that's, it's our sort of, it's the average kind of the sort of the average web that we're seeing here. Tenacious is asking about a particular paper which sounds interesting, but I don't know about it. Let's see. Okay. Tragath is wondering how neural net AI compares to other living multicellular intelligence, plant roots, nerve nets, and things like jellyfish and so on, biofilms. Yeah, well, okay. So one of the big things that's come out of a bunch of science that I've done is this thing I call the principle of computational equivalence, which essentially says that as soon as you have a system that is not computationally trivial, it will ultimately be equivalent in its computational capabilities. And that's an important thing when you talk about computational irreducibility, because computational irreducibility arises because you've got a system doing its computation. There's no system. You can't expect there to be, all other systems will just be equivalent in their computational sophistication. You can't expect a super system that's going to jump ahead and just say, oh, you went through all these computational steps, but I can jump ahead and just get to the answer. Now, the question that is a really good question is when we look at, okay, one of the things that is characteristic of our consciousness, for example, relative to all the computational irreducibility in the universe, is the fact that we have coherent consciousness is a consequence of the fact that we are two things, it seems to me. We are computationally bounded. We're not capable of looking at all those molecules bouncing around. We only see various aggregate effects, point one. And point two, that we believe that we are persistent in time. We believe we have a persistent thread of existence through time. Turns out, big fact of our last few years for me is that the big facts of physics, general relativity, theory of gravity, quantum mechanics, and statistical mechanics, the second law of thermodynamics, law of entropy increase, all three of those big theories of physics that arose in the 20th century, all three of those can be derived from knowing that we human observers are noticing those laws, and we human observers have those two characteristics I just mentioned. I consider this a very important, beautiful, sort of profound result about kind of the fact that we observe the physics we observe because we are observers of the kind that we are. Now, interesting question, I suppose, is when we are limited, we are computationally limited things, and the very fact that we observe physics the way we observe physics is a consequence of those computational limitations. So the question is, how similar are the computational limitations in these other kinds of systems? In a sense, the fungus as observer, so to speak. How similar is that kind of observer to a human observer, and in terms of sort of what computational capabilities it has and so on? My guess is it's pretty similar, and in fact, one of my next projects is a thing I'm calling observer theory, which is kind of a general theory of kinds of observers that you can have of things. And so maybe we'll learn something from that, but it's a very interesting question. Dugan is commenting, ChatGPT can be improved using an automated fact-checking system like an adversarial network, for instance. Could one train ChatGPT with Wolfram Alpha and have it get better? The answer is surely up to a point, but then it will lose it, just like it does with parentheses. I mean, with a network of that architecture, there's a certain set of things one can learn, but one cannot learn what is computationally irreducible. I mean, in other words, you can learn the common cases, but there'll always be surprises. There'll always be unexpected things that you can only get to by just explicitly doing those computations. Bob is asking, can ChatGPT play a text-based adventure game? I bet it can. I don't know, I haven't seen anybody try that, but I bet it can. There's a question here from software. Aside from being trained on a huge corpus, what is it about GPT-3 that makes it so good at language? I think I tried to talk about that a bit, about the fact that that there's regularity in language. I think the particulars of the transformer architecture of this kind of looking back on sequences and things, that's been helpful in refining the way that you can train it. And that seems to be important. Let's see. Victoria is asking, could feature impact scores help us understand GPT better? Well, so what that's about is when you run a neural net, you can kind of you can say sort of how much did some particular feature affect the output that the neural net gave. ChatGPT is just a really pretty complicated thing. I mean, I started digging around trying to understand sort of what, as a natural scientist, you know, I'm like, I couldn't do sort of neuroscience with actual brains because I'm 1,000 times too squeamish for that. But, you know, I can dig around inside an artificial brain, and I started trying to do that, and it's difficult. I mean, I didn't look at feature impact scores. I think one could. Okay, so, but by the way, I mean, I'm amused by these questions because I can kind of, you know, I can still tell you guys are not bots, I think. And let's see. Ron is asking about, I have to work late tonight. What does that mean? Yeah, absolutely. ChatGPT is learning stuff like that because it's seen, you know, a bunch of text that says I have to work late tonight, so I can't do this. It's seen examples of that. It's kind of doing the Aristotle again. It's just seeing this, you know, these patterns of language, and that's what it's learning from, so to speak. So yes, these things we might say, how do we think about that formally? Oh, it seems kind of complicated to us, but that pattern of language has occurred before. All right, last thing perhaps. Okay, Albert is asking, do you think humans learn efficiently because they're born with the right networks to learn language more easily, or is there some difference? I think it is important. The architecture of the brain undoubtedly is important. I mean, you know, my impression is that there are, you know, it's a matter for the neuroscientists to go and find out. Now that we know that certain things can be made to work with artificial neural nets, did the actual brain discover those things too? And the answer will be often yes. Just like there are things we probably have learnt from, you know, the flight of drones or the flight of planes, that we can go back and say, oh, did biology actually already have that idea? I think that there are undoubtedly features of human language which depend on aspects of the brain. I mean, like, for example, one, you know, talking to Terry Tsanovsky, talking about the loop between the basal ganglia and the cortex, and the possibility that, you know, the outer loop of ChatGPT is a little bit like that loop. And it's kind of like, I'm turning things over in my mind, one might say. Maybe that's actually a loop of data going around this literal loop from one part of the brain to another. Maybe, maybe not. But sometimes those sayings have a habit of being more true than you think. And maybe the reason that when we think about things, we have these certain time frames. When you think about things, there's certain times between when words come out and so on. Maybe those times are literally associated with the amount of time it takes for signals to propagate through some number of layers in our brains. And I think that in that sense, if that's the case, there will be features of language which are, yes, we've got this brain architecture, we're going to have these features of language. And insofar as language evolves, as so far as it's adaptively worthwhile to have a different form of language that is optimized by having some different form of brain structure, that's what we're being driven by natural selection and so on. I mean, I think, you know, there are aspects of language like we know if you know, we tend to remember 5 chunks, you know, chunks of 5, so to speak. things at a time. And we know that if we try and give a sentence which has more and more and more deeper